हम सबके लिए अलग है, हाइपर पर्सनलाइज्ड ड्रीम है, राइट? किसी की चॉइस रेड कार हो सकती है, किसी की ब्लैक एसयूवी हो सकती है, किसी का बंगलो हो सकता है, किसी का टॉप वाला अपार्टमेंट हो सकता है। सिमिलरली एआई भी इसी तरीके से काम करता है। उसके अंदर ट्रिलियंस ऑफ डेटा सेट्स डाले जाते हैं, जिसके बेसिस पे वो एक हाइपर पर्सनलाइज्ड पैटर्न जनरेट करके देता है। जैसे हम क्वेश्चन पूछते हैं, जितने अच्छे तरीके से प्रॉम्प्टिंग करते हैं, जितने अच्छे तरीके से क्वेश्चन पूछा जाता है, वो वैसा ही एक ड्रीम जैसा आंसर आपके लिए निकाल के देता है जो कि आपको चाहिए। सिंपल। ओवर टू यू देव।
Perfect. So AI based user, my first question was how many people have used AI? So अगर इसको simply put करें, we are surrounded by AI machines, phones, speaker, right? Everything, you're driving car, everything is, we are surrounded by AI. So these are the primary use cases which most of the people have quite aware of. The first one is auto driving car, right? Tesla is the biggest example who has pioneered into this. The second one is for healthcare faculty. So this is one of the leading research firms in US who are doing the automatically detection of tumors in the brain cell, even in the early stages, because if it goes into the last stage, the diagnosis will be very, very difficult. So this is also the use case which I think most of the biggest of the companies are doing it. Amazon, Google, Microsoft, everyone is putting the money on detecting the this one.
कैंसर जब तक के थर्ड या फोर्थ स्टेज पे नहीं आता, बिना बायोप्सी के कोई डिटेक्ट नहीं कर सकता. So imagine there's a software which is actually detecting a tumor on the first stage itself, or the second stage itself.
Yeah. Third one is everyone is using Google Map or Apple Maps, right? So it is properly AI driven. No one has put up the maps there. Everything is properly AI driven. So everything is properly generated. What is the traffic density? What is the time period from going from one point A to point B? When we are using our Siri, Apple phone or Android phone, right? There is a voice, the native is voice commands, right? So those are also the part of the AI, which is actually getting trained continuously when you are speaking to someone else, right? Credit card frauds, everyone is already aware of it. Text, audio and video content generation, which you have already seen in Gemini, ChatGPT, and lots of Facebook models as well. So let's go to a little bit of the things on the how many learning systems are in the AI world. Do not get confused what the data represents. So it's a simple Venn diagram. As you can say, it is a combination of set and subset theories. So in this scenario, the artificial intelligence, which is the superset, so that encompasses everything which is under that. So machine learning will be the subset of artificial intelligence, representational learning, deep learning, and generative AI. So as you can see, the generative AI, which is a current trend with respect to the GPT and the Gemini world. So this is the very, very niche AI machine learning systems. So what is the difference between all these things in a simpler sense? When we are going from right to left, the data, amount of the data which these machines or these algorithms are getting trained are exponentially increasing. For machine learning algorithm to work perfectly, thousands of the data points are okay. When we are going for the representation, millions. When we are going for the deep learning part, billions of the data. And when we are thinking about the generative AI, trillions and trillions of the data. So means the only difference, the same algorithm will work, the only point is that how much amount of the data you are putting into the system, and basis on that, you have already seen in the generative AI part that you can actually generate the similar kind of a content which the normal human does it.
So imagine this like an Indian family. एक घर पे रहते हैं सब लोग. सबसे बड़े जो ग्रेट ग्रैंडफादर है वो आर्टिफिशियल इंटेलिजेंस है, उनकी अम्ब्रेला के अंडर मशीन लर्निंग है, रिप्रेजेंटेशन लर्निंग है, डीप लर्निंग है, और सबसे छोटा और सबसे ज्यादा जैसे कि नई जनरेशन आती है वो हमसे ज्यादा स्मार्ट होती जाती है, ज्यादा लर्नड होती जाती है. सो जेनरेटिव एआई वो सबसे ज्यादा छोटा और सबसे ज्यादा स्मार्ट बच्चा है, लेकिन उसको जो नरिशमेंट चाहिए, जो कि पिछली 5 जनरेशन सीख के सबकॉन्शियसली उसको नरिशमेंट दे रहे हैं, वो भी ज्यादा लगता है. इसलिए जनरेटिव एआई के पास में सबसे ज्यादा डेटा चाहिए होता है, क्योंकि वो सबसे ज्यादा एक्यूरेट कैलकुलेशन कर सकता है, सबसे ज़्यादा एक्यूरेट पैटर्न जनरेट कर सकता है.
Okay, so let me also tell you a little bit history. So when you guys think that when the AI systems getting invented at what year or the century? Can sorry, 19?
15.
Yeah. So the first AI system was built in 1940 into the regime of Hitler. So that is the first time someone has created the system in the cryptography world, right? Which is very, very high level of cryptography. In the 1942, because of the high encryption protocol, which was used as a communication between the German agents, there was no one will be able to cipher that. So guy who's very, very well known in the artificial intelligence, Alan Turing. So Alan Turing created a logic which is based on the analog signals and lots of the digital processing, and basis on that he created an algorithm which actually cracked the encryption code, and that is the first level of AI which got introduced. So that is how the evolution of the AI happened. Lots of the things, our topic. What is the definition of machine learning? I'll not go much deeper into each and every aspect of it, but this is one of the scenario which everyone has to understand it. Machine learning. The best part in the AI world is that all the words are very, very easy to understand. Machine learning, machine is learning. Very simple. So when and how the machine is learning? From the data. On the left part of the flow diagram, as you can see, this is the traditional approach about how a normal human being solves a problem statement, right? So first one is the human study the problem statement, they write rules. Rules means A or B or C, if and else conditions. Lots of if and else conditions happen, and basis on that, basically you write the rule and you evaluate the output. So that is how the normal traditional approach of solving the problem statement happens. And then when you evaluate it, you analyze the error. When you analyze the error, if the error is too much, then you study the problem again, then you write the rule again, then you do it. It is an iterative cycle. You do it in the iteration manner, and once you find that the output is correct and the errors are less, then you launch your product or launch your thesis. In the second program, in the second diagram, which is a machine learning approach, in this scenario, there is no set of rules. Rules are a condition which are 0 or 1. But in the machine learning approach, there is nothing called 0 or 1. Everything is a probabilistic model, means the probability of something happens is between 0 and 1, right? So 0.5% of the 5% of the possibility something happened, 50% of the possibility something happened. So all the rules, if we accumulate all the rules, and putting into the training algorithm or putting into as lots of the data and train the algorithm, and basis on that the same process flows back again. Study the problem statement, train the algorithm, putting lot of the data, and the cyclic process start happening. So in this scenario, what happens? You are all not basically constrained only by few rules. You are constrained by everything which is come under the sun. It is totally up to you how much data you can provide. And that is how when we are thinking about the machine learning approach, the probability to solve the problem statement is much faster, easier, and also contextual.
एक बहुत सिंपलिस्टिक एग्जांपल, मैं गूगल से पूछता हूं मेरे को ए पॉइंट से बी पॉइंट पे जाना है, गूगल मेरे को 4 ऑप्शन देगा रूल्स लिख के, आप पैदल जाएंगे इतना टाइम लगेगा, बाइक से जाएंगे इतना टाइम लगेगा, ट्रेन से जाएंगे इतना टाइम लगेगा, राइट? प्रोबेबिलिटीज दे रहा है, 4 प्रोबेबिलिटीज है, ऐसे जाएंगे तो इतनी जल्दी पहुंचेंगे. बट गूगल ये नहीं देख रहा कि अगर उस रास्ते में कोई ट्रक पलट गया तो क्या होगा. वो सेकंड केस में हो रहा है. वो इतनी सारी प्रोबेबिलिटीज निकाल रहा है. गूगल ने मेरे को बोला 0 है या 1 है, आप इतनी देर में इस जरिए से इतनी देर में पहुंचेंगे. लेकिन वो ये प्रोबेबिलिटी कैलकुलेट नहीं कर रहा कि अगर किसी ट्रक का एक्सीडेंट हुआ तो वो सारा का सारा लेट हो जाएगा. जैसे ट्रैफिक जैम्स में होता है 15 मिनट्स टू रीच योर डेस्टिनेशन दिखाता है, बट यू रियलाइज नो इट्स ऑलरेडी बीन 22 मिनट्स, बिकॉज गूगल कैनॉट कैलकुलेट, द मैप्स कैनॉट कैलकुलेट कि वहां पे क्या चल रहा है. ऐसे आपका टायर पंचर हो गया, गूगल को नहीं पता है। सो इन केस ऑफ मशीन लर्निंग वो सारी प्रोबेबिलिटीज काम में आ रही हैं, इसलिए वो कभी भी 0 या 1 का डिफाइंड आंसर नहीं देता है, मल्टीपल प्रोबेबिलिटीज देता रहता है।
Perfect. Good example, Navdeep. And let's take a use case on the top of what Navdeep said. So, how do you calculate the accurate time when there is accident happens somewhere, let's say 10 kilometers down the line? Then how these kind of a Google Map system also predicts the same thing? How do you do that? Because it has already been fed all the data which is related to the roads, but not with respect to the accident, which is happening right now, which no one can predict. Then how you can build up a system which is accurate, point by point, time efficient system? How do you do that? Anyone? Yes. The accident is happening right now. There is no past data.
Okay, but maybe because maybe it analyzes to certain cases like what happen if, say for example, 100 accident happen on that road in the year. So average time or something like that.
Very good answer. And basically, you are predicting that how many accident happens into multiple scenario, and basis on that, what is the time duration which might occur. Right?
एक प्रोबेबिलिटी डिस्कस कर रहे हैं, हो सकता है उस रोड पे हमेशा कंस्ट्रक्शन वर्क चलता रहता हो।
बिल्कुल. So in this scenario, lots of the people, especially in intelligence community means CIA of the world, military intelligence, and India raw. So all these three people are continuously feeding the data to the machine learning system, which is real-time camera-based traffic detection. Real time. So means now you are not only giving the past data, you can also give the live data. The live data requires lots of computation, which is not possible into the current processing world of the computer science. So that's how, when we are thinking about real-time feeding of the data, then it requires a different level of computing.
That is the reason Google की accuracy Apple Maps से इंडिया में ज़्यादा है, और फॉरेन कंट्री में Apple Maps की accuracy Google से ज़्यादा है, क्योंकि नंबर ऑफ Apple यूजर्स फॉरेन कंट्री में ज़्यादा है और नंबर ऑफ Android यूजर्स इंडिया में ज़्यादा है. Simple.
Perfect. So in this scenario, what happens? Have you guys heard about quantum computing? पढ़ा है कहीं पे, आप लोगों ने सुना है, या आयरन मैन मूवीज तो देखी होंगी, राइट? So quantum computing is a new paradigm, and everyone knows that when we are thinking about the atom, the 99.99% of the space in an atom is empty. So if that space is empty, means that can be stored as that empty stored space can be used as data. The processing of electron is much faster than anything which we have seen. It is works as light speed. So they are thinking about quanta. Quanta is a light which has a energy. Quanta is a minimalistic energy which is on the photon level, on the light level. So on the real-time data, when you feed the real-time data, when you feed the past data, and you want a real-time analysis, the current paradigm of the processing will not work. So that's how even the machine learning algorithm and everything is getting evolved, but also the computation power has to also get evolved. So can I put the laptop there, because I think it is not captured. Excuse me, can you just put it there, because it is not capturing the signal. Yeah, it's good. Thank you. Yeah, so there are three types of machine learning algorithm. One is supervised, second one is unsupervised, and semi-supervised. As the name suggests, supervised, कोई तो supervise कर रहा है. So human are supervising it. Let's say, for an example, there is an example here. Let's say if we get thousands of images and we have to classify what is horse and zebra. So we have to feed the information into the machine learning supervised algorithm that these kind of animals are horse, these kind of animals are zebra. And as soon as you start feeding those data, the machine starts learning. And later on, if you give a picture of lion, it immediately says no horse, no zebra. Right? Sometimes in the initial stage of the learning, the machine learning can suggest that zebra is a horse or horse is a zebra because of the error, because of less data which is fed into the system. But as soon as you start feeding the data, as soon as you start labeling the data by human, the machine becomes intelligent. जैसे बच्चे को आप ये यूज केस बताते हो, ए यूज केस, बी यूज केस, सी यूज केस, जैसे जैसे उसके यूज केसेस होने लग जाते हैं वो बच्चा इंटेलिजेंट होता जाता है.
दिखता तो सेम ही है, जिसकी स्ट्राइप्स होंगी वो ज़ेब्रा होगा.
करेक्ट, राइट. लेकिन कभी कभी आप शेडो में पेड़ के नीचे हॉर्स के भी स्ट्राइप आ गए, प्रॉब्लम आ गया. Right? So there are multiple combinations which happen. So machine learning and supervised learning take care of these scenarios. Some of the scenarios will not be taken care by supervised learning. That will be taken care by unsupervised learning, which human intervention is not required. Where the machine is learning everything by itself. Similar like Google Map. There is no human there. Satellites guess the data that this is some road, this is something else. As soon as the user starts interacting, the machine starts learning and it will plot everything. Yeah. One minute. Then one. So the third part of the learning system is a semi-supervised, which is a combination of both. That some of the data set you give as a labeling, as an instruction, and rest of the things will be taken care by the machine itself. Let me go to the next slide. So there are two kinds of algorithm which generally we will cover it today. One is a classification algorithm. Classification means classifying between two things. Let's say in this scenario, the mail, everyone is sending the mail. So some of the scenario, what happens, there are lots of the mails which are coming, which is some of the mails are relevant to you and some of the mails are irrelevant to you. And that becomes very, very challenging because spams mail are bombarding the system. We do not know if we are starting classification of the spam and non-spam. It is very, very difficult for us to take care of it. But when we are thinking about the machine learning classification algorithm, slowly the machine will start learning that in the event of the spam, it is happening to which class? Class A, let's say spam. Class B, let's say non-spam. So in this scenario, as soon as you start labeling it, for an example, you got a mail from XYZ something@something.com. You label it, no, this is spam. The machine starts learning. The Google algorithm or the Microsoft algorithm starts learning, and they classify that these kind of emails with these kind of content are spam. These kind of content are not spam.
कभी ऐसा होता है किसी फ्रेंड से ईमेल आया, आपको रिसीव नहीं हुआ, क्या कहते हैं सबसे पहले स्पैम में चेक कर लो एक बार, राइट? सो कहीं ना कहीं वो एल्गो चल तो रहा है, बट देयर आर सम इनएक्यूरेसीज. गूगल ऐसा डिटेक्ट कर रहा है कि ये आदमी आपको जानता ही नहीं है और सडनली ईमेल भेज रहा है क्योंकि आपका पास्ट में इस टॉपिक से या इस पर्सन से या इस कंपनी से कोई इंटरेक्शन या कोई लर्निंग हुई ही नहीं, इसलिए वो ऑटोमेटिकली स्पैम में डालता है. फाइनली गो टू द स्पैम एंड यू फाइंड दैट ईमेल इज ओवर देयर. सिमिलरली ऐसे ही जब ईमेल्स आते हैं, अगर आपने देखा हो कंपनीज के जो प्रमोशनल ईमेल्स आते हैं वो कभी भी एक सिंगल सब्जेक्ट लाइन के साथ नहीं आते. ABCD14398 their company name. सो गूगल उसको रीड कर लेता है, नहीं ये डेफिनेटली स्पैम ही है. और इवेंचुअली अगर 100, 200, 500 लोगों ने उसको स्पैम किया तो एंड ऑफ द डे जो एड के बाद में जो कंपनी का नाम है abc.com, उस पूरी की पूरी कंपनी की ईमेल्स को ही स्पैम में डालना शुरू कर देता है. दैट्स एग्जैक्टली हाउ गूगल डज इट.
So the next, just a minute, yeah. So the next one is a regression problem statement. The regression is nothing but predicting the value of something basis on the input which you have provided. So in this example, let's say there is a plot between the experience and the salary, right? So let's say the 2 year of the experience of the person will have a lesser salary than 10 year of the experienced person. So in this scenario, what if you provide all these data and you ask that what is the salary of, let's say, a person who has 17 years of experience? So those are the things can be very, very easily predicted. So these are the continuous outcome. right? So in this scenario, as you can see, there are lots of the data points which are happening. The data points are the relationship between the x and the y variable. In this scenario, the salary and the experience. So we draw a line which is a best fit line. The best fit lines actually are those lines which give you the best of the representation of the data set. So means lots of the points are around this line. So means we can take care in a very high probability that if the user will have expectation. So this is of the regression works.
इस स्लाइड को समझने के दो तरीके हैं. पहली बात तो वो एक बीच में मीन लाइन है कि अगर आपका एक्सपीरियंस ग्रो कर रहा है एआई के बेसिस पे तो आपकी सैलरी ग्रो कर रही है. एंड वो डॉट्स हो सकता है कि उस सैलरी के थोड़ा सा नीचे हो या थोड़ा सा ऊपर हो, राइट? लेकिन ये वाला स्लाइड रियल लाइफ सिनेरियो में बिल्कुल गलत है. मेरा एक्सपीरियंस तो बढ़ रहा है लेकिन सैलरी नहीं बढ़ रही है, सैलरी उतनी है सर, मैं क्या करूं?
तो इससे ये पता चलता है कि हमें कुछ और सीखना पड़ेगा या कुछ करना पड़ेगा. तो एक्सटर्नल फैक्टर हैज टू गेट इन्वॉल्व व्हेन यू आर थिंकिंग अबाउट दीज काइंड ऑफ अ सैलरी प्लस एक्सपीरियंस एक्सपेक्टेशन. So now comes to a very basic math which is covered into, let's say, class of 8th or 9th, which is a very simple line equation, which is in the x coordinate there are input variables, on the y coordinate there are output variables. So as you can see over the line, y is equal to mx plus c, at x is equal to 0, y is equal to c, right? And slowly as you can start putting up the things on x1, x2 or x3, you can actually predict y, correct? Very simple equation. There is nothing wrong about it. So in the machine learning, let's think about this line representation or equation representation with respect to machine learning. So all the points which are representing on the x are called features. Features कैसे होते हैं? For a human face, ear is a feature, eyes is one feature, right? Nose is another feature, and y is variable. Y is an output, targeted variable. So in this scenario, what can be basis on the face? Can I detect that this particular being is a human or animal or someone? We can predict it. So think about it that each and everything which is like ear and nose and everything, it represented into a number, because machine cannot read these things. Machine can only and only think in numbers. So if everything is represented into the number, then easily we can get the y, which is the output value.
Remember we spoke about how the value cannot be between a 0 or a 1 in the case of when we're traveling through the Google. That is the reason why 0 के बीच में दिखाया गया है उस ग्राफ में. Graph before this.
So in this linear equation, so हमने जो अभी line देखी वो उसमें एक variable था x. Let's say there are multiple variables, x1, x2, x3, x3, everything. Okay. So and the theta are the weightages. Okay. So I'll come to what is the weightages. Can anyone explain me what are the weightages in this scenario? कोई नहीं. आगे हम लोग एक एग्जांपल के थ्रू समझेंगे.
अगले स्लाइड में समझना.
So in this scenario, अगर the same equation will get extrapolated with multiple input variables and find an output. So now this is a very classical problem statement which machine learning starts solving since 1950s or 60s. To predict